All right, a sample is composed of carbon, hydrogen, and oxygen. When 0.5943 grams was subjected to combustion analysis, it produced 0.8861 grams of CO2 and 0.717 grams of H2O. What is the empirical formula? All right, to get the empirical formula, I need the actual masses of the carbon, oxygen, and hydrogen, and I didn't give you any of those. So we're going to actually figure out the mass of the carbon by looking at that 0.8861 grams of CO2. We just need to figure out what amount of that is actually the carbon. So I'm going to combine these into a couple steps. So down here at the bottom, I have the molecular weight of CO2, which is 44.01. On top, I just have one carbon because that's how many carbons are in CO2. Now I'm going to have something similar for the 2717, but it's for water. So on the bottom of this one, I have the molecular weight of water. And on top, I have 2 times the molecular weight of hydrogen because there's 2 hydrogens in water. All right, using those 2 numbers, or those 2 calculations, will give us the starting point here. So 0.2418 of just carbon. And that is 0.03040. Okay, now that's 2 of my starting things, but to get the empirical formula, I also need to have, in this case, the mass of oxygen, the other species. That I'm going to get by subtraction. I know how much the original sample weighs. I know that 0.24 grams of it is carbon and 0.03 grams of it is hydrogen, so everything else must be oxygen. So 0.5943 minus 0.2418, also minus 0.0304. I get that the amount of hydrogen is 0.3221. All right. Now, once we got to this point, we just do the conversion to the empirical formula like we would if I had given you the masses of those. So I'm going to take each one of these grams and divide it by the molecular weight of the atom it represents. All right, so since I got that 3221 in there, I'm going to divide that by the 16.00. And that's 0.02013. I guess I should put those in there. Those are known. So 0.0304 divided by 1.008 is 0.03016. These are moles. And the last one, 0.2418 divided by 12.01 is 0.02013. All right, so one of the ends, so the carbon or the oxygen is my smallest, so I'm going to divide all of them by that value, which really just means I'm dividing that 0.03 by the 0.02. And I get a 1.5. So we got an empirical formula with fractions of 1, 1.5, and 1. Can't have 1.5, so we're going to double all these. So my empirical formula must be C2H3O2.